Okay, hi everyone. Today we're going to solve another problem that is LeetCode 198 house robber. It's a medium level problem and it's a very standard problem for the topic which we are going to see. And it has a very decent like to dislike ratio. So let's get excited for this problem and solve it. So we are a okay. So the question says that you are a professional robber. Robber, someone who robs or a thief planning to rob houses along a street. Each house has a certain amount of money stashed, which means money that is associated with every house. So this line says that every house has some amount of money. The only constraint stopping you from robbing each of them is that adjacent houses have security systems connected and it will automatically contact the police if two adjacent houses were broken into on the same night. Okay, so what this question says is, let's say you are given, so this is a road and these are houses. This is house 1, this is house 2, this is house 3, and this is house 4, right? So the money in house 1 is 1, in 2 it is 2, in 3 it is 3, in 4 it is 1. And these are houses number. So the number are, this is house 1, 2, 3, and 4. Fine. Now the condition is, if a robber broke into this house and take all this money, then he cannot broke into the adjacent houses, which means he cannot take money from these houses, although he can take money from the fourth house but not the adjacent houses, right? He can take money from the fourth house because that's not an adjacent house to house 2. And that is all the question is. Now one must say that we can follow a greedy approach, but greedy approach will not work because you will have no information that which house is best to start with. So if you will start with this house, then you cannot go to this house, but you can go to this one, right? And the answer with starting with 1 is going to be equal to 4. But if you go with another approach and let's say you start with 3, yeah, then also it will be 4. But I think you can easily make a test case where this condition will fail. So let's say we are, yeah, so there will be, you can understand there could be a test case where, or let's say you have money associated with house 3, this and this. In this case it will be 3, right? If you take this house and then this house. But if you start with this one, then it will be 4 because then you will take this one. So greedy approach will not work. Let's now try to write a recursive solution for this one. Why recursive solution? Because you can see, if I start with this house, then I'm saying that with this house I can get with the remaining elements, because I will not be taking this one, but this is the array which I need to further study and select which house should I next rob, right? So this recursive problem is, if I have, let's say, these houses, then I will have a recursive solution that, okay, start with a house that is x, and if you start with x number of house, the xth house, then the remaining houses will, then out of those remaining houses you will have your other answer, right? And that will be equal to the money that is associated with them. So what I want to say is, this is nothing but a like kind of like a knapsack problem where you have this option of pick this one or not pick this one. So let's say I pick the house number 1. So this is a solve function, and solve function says that, and let me just write them as the index rather than 0 1 2 3, rather than the house number. So if I pick the 0th element, right, if I pick 0 element, then if I pick 0 element, then I will have 1 as the money that I will record, right? Because at 0th house I have 1 money associated with it. And if I pick 0th element, then I cannot pick this element, right? Then I have this index. Then I will say that from now start this array. Now the array that I want to solve starts with 2, right? Because at this point I'm saying that the array that I want to start with, that array that I want to work on starts with 0th index. That is why s of 0, and in this case it is s of 2. By the way, this s of x is a recursive function which will give you the maximum money a robber can attain, right? This is the function and this will give you the requirement, and this will give you the required value. Now if you say that okay, I don't want to take 0th house, okay, then what will happen? So if you don't take the 0th house, right, in that case you are not taking this house, right? So you are saying I'm going to ignore that house, then you can obviously take a house out of these two values, but the money associated with this house will not be added, which is why it is 0 plus of house. Now this array starts with 1, so you will say s of 1, right? And from house, now from s of 2, now we want to solve s of 2, this is 2 and 1. And in this case you will take, I will take the first element, or I will not take the first element. If you will take the first element, then you will have 2 as your answer, right? Because the money associated with the house 2 is 2. And then you will solve for the remaining part, and that is s of 4. But s of 4 will give you 0 because that house is not there, that is not present in the neighbor or road or whatever in the street. But if you don't take s of 2, then you have an option to take s of 3. So you will say 0 plus of solve for s of 3 now, because this is the only array that is left to you, right? And if you will take, now you have options, either you can take s of 3, or you cannot, or you won't take s of 3. So if you take s of 3, then the money you will get is 3 plus of the remaining value. There is no remaining value, so you will just say 3 because that's the last index. And or you can also say, because in the implementation we won't be having a base case to identify the last house, so we will simply call another function that is s of 5, right? Because 2 plus, because if we are taking the element, then we need to add 2, because we cannot go on the adjacent element or the right next element, right next house basically. But if you don't take s of 3, then you will say that okay, I will not take it, and the next house that I want to go on is s of 4, and that is also not present, so you will return 0, you will return 0. Now this function says the max money a robber can attain from an house. So at s of 3, right, the max money that you can have is 3 or 0, because this s of 5 will be 0, and this s of 4 will return value as 0, and this 3 plus 0 is 3, and 0 plus 0 is 0. So s of 3 value will be the maximum, right? If you don't take, or if you take, it will be the maximum value. So s of 3 will say that I will give you 3, right? Because that's the maximum value, and 0 plus 3 is 3. Now s of 2 value 1 is 2. So 1 is 3. If we don't take s of 2, then we will have the value as 3. But if we do take 2, then it will give you the value of 2. So which one is better? We should always go with 3, right? So I will say that okay, take the s of 3 value as 3, and 1 plus 3 is equal to 4. So this is one value. This is the one tree that we have solved. Now we will backtrack to the main part, and now I won't take the 0 value. Then I will say at s of 1, we have an option either to take the value or not take the value. So I will take the value. At s of 1, I will say 1 plus of the remaining part is s of 3, the remaining array. And if I don't take the value, then I will have 0 plus of the remaining element array is starts with second index. And then if I take 3, or I don't take 3, if I take 3, then it will give me the value of 2, and the next array that I want to look for is s of 4, not 4 actually, because we are at, okay, sorry, so we are at 3, the value is 1 plus s of 5, and s of 5 is 0, so this will return 0, and 0 plus 1 is 1. And if I don't take s of 3, then I can go to the next element, and that is 2. So I will call this 0 plus s of 2, right? Now sorry, s of 4, and s of 4 is 0, so this will return 0. Now out of 0 and 1, which is the maximum value? So it has the maximum value as 1. So at s of 3 you will have 1, and this value will be 2, and s of 2 value, now we have to calculate s of 2. So there is two options, pick or don't pick s of 2. If we pick the s of 2, then it will be 2 plus of s of 4, and if we don't take s of 2, then it will be 0 plus of s of 3. So if we, yeah, so fourth is the base case, it will return 0, so 2 plus 0 is 2, And s of 3, we have case either to take or don't take. If we take s of 3, then it will be 1 plus of s of 5. Or if we don't take s of 3, then it will be 0 plus of s of 4. And none of them is going to give me an answer, so it will be 0. So this is 1, 0 plus 1 is 1, and this is 0 plus 0, that is 0. So s of 3 will give you the value as maximum value as 1, right? Because out of these two, 1 and 0, you will be deciding which is the maximum value, and the maximum value happens to be 1, so you will return it. Now 0 plus 1 is 1. Now 1, now s of 2 will give you the value, the maximum value, and that is 2. So s of 2 will give you the maximum value as 2. Now 0 plus 2 is 2. Now s of 1 will give you the maximum value, that is 2, because 2 and 2, 2 will be the maximum value, and this is 2. So out of these two, which is the maximum value? The maximum value is 4. So your answer will be 4. And in this case, answer is 4. So this is the problem. This is a recursive solution, and this recursive solution is going to take order of 2 raised to the power n time, because we have two options, either to take or not take the element, and n is the size of the element, n is the size of the array. And space complexity wise, it will again be 2 raised to the power n, because we are using recursion, and it will have a function stack which has the value of 2 raised to the power n. Now let's write this code. Yeah, actually it's not 2 raised to the power n in the space complexity part, because we will be backtracking and we'll be removing the functions. So because of that, I think it won't be 2 raised to the power n as space complexity. Space complexity will be equal to n only, right? Because we are stretching the tree, and the height of the tree is the space complexity. So that is, I think, equal to n only. Yeah, makes sense. Now let's write the recursive code, and then we will optimize it, because this recursive code 2 raised to the power n will give you a TLE, because the nums length could be 100, and 2 raised to the power 100 is a ridiculously large value which will give you a TLE by no guess. So the first case is the first thing is, let's say, just return a solve function, and it has nums as the argument, and then it has the index, that is 0, the initialized index, and then you are returning a max function, so that is why return data type, so return int data type, and you have a vector of int reference nums, and then you have int I, that is index. Now the base condition will be, if I is greater than or equal to nums dot size, then you need to return 0, because now you are out of the bounds and you won't get anything from the houses that are not listed in the society, so you will get 0 money from them. And the last thing will be return. Okay, so now you have two options. The first is, so, and out of these two options you will be returning the maximum value, right? So the first option is, if you choose the current house, then you will have that value, nums of I, which means money of I, you will have that money. But now you cannot go to the right next house, you will be going to the next house, that will be I plus 2, because I plus 1 will be an adjacent right next to right next house, right? Which you cannot go, because that's stated in the question that you cannot go to the adjacent house. And if you don't take this, if you don't choose this index, then you will not get the money from that house, so that will be 0, and you will be solving for the nums of I plus 1, right, the next house, and that is the solution. So if we will run this problem, if you don't have any errors, yes, it will run, but it will give you a TLE, and you can see that. Cool, it is giving you a TLE. But in order to optimize it, we will be using dynamic programming. And why dynamic programming? Because if you can clearly observe, when we are creating this tree, there were multiple times, I think we have 3 times since we have calculated s of 1. Why are we calculating s of 1 again and again, right? We can easily, conveniently store the s of 1 value in the data structure, and whenever that is required, we can use that value. So why not use dynamic programming for that, to memorize the past result? So I will say dp of nums of the same size as the array, and initialize with -1, because it's a memoization, and we will pass dp here, dp here as well. And if we have a memoized value with us is not equal to -1, which means the value is memoized and stored with us, so I will return that value. And we also need to store that value, so I will say dp of I is equal to max of this value. This is a top down method. Okay, I need to pass dp here as well, and this should have its data type, that is vector of int reference dp. Okay, it is working, and I think it will get accepted as well. Yes, it does, and it is performing, I don't know, okay. But now let's convert. So this is the top down dp. Now let's convert this top down dp to bottom up dp. So let's just have this solve function as it is, and in order to convert this thing, what we will do is we will say that, okay, let's observe this top down dp. So I is incrementing, right? I is going on the next element, and that is how it goes. But the value that we are selecting is either I plus 1 or I plus 2, and it's a top down method, and it is very much and it is very fine because we are using, and because we are, top down method says that f of 2 is equal to f of 2 plus 1, that is 3, or f of 5, not 5, 4 actually, 4, right? In top down method we rely on the values that are in the downward direction, right? When we are constructing this tree, then f of 3 and f of 4 will be found in the downward direction as compared to f of 2. And in a top down method we rely on the values, we get these values first, and then these values will give the value for the upper part, or the upper part of the tree. So this is a top down method. But in bottom up method we rely on the past values. So for example, if we have calculated some values already, right? For example, you have this array and you have calculated some values already, then you will be able to have these values at this point with the help of the values that you have already calculated, which is why it is known as bottom up method. Because if you will see a tree, then this will be x, this is y, this is z, and because of a, and a can only be calculated because you have these values, that is x and y, right? That is why it's a bottom up method. So in order to have a bottom up method for this one, I will have the vector with the initialized value of 0 for dp, and yes, now I will say that for int I is equal to 0, I is less than nums dot size I plus plus. Now, so dp of I will be equal to, so if, yeah, the first thing will be, so dp of 0 value. Now this will be equal to nums of 0 because it doesn't have any choice to either, because at past there is no value, right? So it doesn't have any choice but to have that value. So it will say n nums of 0, and dp of 1 will be equal to, yeah, so dp of 1, let's say we will write a code for dp of 1, and yeah, let's have dp of 1 value as well. So dp of 1 is equal to max of, just a second guys, yes. So now you have these two options. So dp of 0, which means that if you only have first house with you, then what is the maximum profit that you can have? What is the maximum money that you can rob? That will be only the money that is associated with the first house, right? So which is why dp of 0 is nums of 0. But if you have two houses and they are adjacent, as obvious, then what is the maximum money that you can have? Then the maximum money will be out of these two houses, because if you rob a house 1, then you cannot rob house 2. If you rob a house 2, then you cannot rob house 1, which is why the maximum of nums of 0 or nums of 1, this will be equal to the dp of I. Now this point should start with 2, and this will say that dp of I is equal to max of, now the current num is added. If the current num is added, then we need to have the this is like, if you are using this a pointer, if you are saying that I'm going to pick this house, then you cannot have z because that's an adjacent element, so you will have y, which is why you will say nums of I is added, then dp of I minus 2, not I minus 1, because that will be just an adjacent house. But if you don't take this house, then it nums of I will not be added and will be dp of I minus 1, right? And then you will return simply the dp of nums dot size, or just the back element dot back, and that now you are done. Well, not exactly. The reason is, if you only have, because there are some edge cases, corner cases, and that are um yeah, so nums of length could be 1, could be 2, because if it is equal to 2, right, in that case this will work. But if it is equal to 1, then nums of, so dp of I, so at the first place we cannot have this value, which is why we need to address this case separately. And I will say dp if nums dot size is less than equal to 2, sorry 1, is less than equal to 1, because yeah, sorry, if it is less than equal to 2, in that case I'll be returning the max value out of these two, and that will be equal to max element nums dot begin nums dot end, right? Now you must be wondering why I've used this max element. I can also say max of num0 and nums1, but that is not the case, because we can also encounter a situation where nums dot size could be equal to 1. And in that scenario, nums of 0 and nums of 1, but nums of 1 will give you a runtime error of overflow. So we are not going to do that. And in order to safeguard us from that corner case, we will say max element out of the nums dot begin and nums dot end. It will be constant operation, because we can only have two elements at max, and at minimum we can have only a single element. So this is the case. Let's see if this will work. Okay, nums, it should be nums. And it does work. Let's try submitting it. Okay, and it is very fast, but the space complexity is not so good. So let's see, because this clearly states that there are some users who have solved it in a much better space, because we are only able to beat 25% of the overall users. Let's see how we can solve this. So you can see that we are constructing this solution in this way, right? So if we are on this present value, then we are using the past. So let's say we are on this present value, then we are using the past, and then we are using the past, right? The past of past. So, and when we are moved on, this is the array, this is the house, and this is the house. This is the information that we need for this present house. But if I move for this house, then this is my present, this is my past, and this is my past, right? So we only need three variables. Why we are using a linear data structure for this, like an array? So let's reduce it to that part. And I will say that, so int, so the first thing is the past variable, that is equal to 0. Then we have a past variable that is equal to 0. Then we have an answer variable that is equal to 0 as well. And now I will say that answer, and this is 0, because now we can start with 0. We are not using, because we won't be encountering an index out of bound issue or overflow runtime error. So we can say that answer is equal to max of, now if we are keeping this element, then nums of I. And if we have this element, then we cannot use the past value, right? Because if we are keeping this house value, then we cannot use the past value. We will be using past. So I will say past. Otherwise, if I don't take this value, then I can use this past value. So I will say past. But this is not where it ends. Now we need to shift these values, right? Because initially we have present here, and this is past, and this is past. But when we move forward, the past will take the value of past, and past will take the value of present. So I will say that past is equal to past, and past is equal to the present, that is answer. And then I will simply return answer. Well, the test cases were passed. Let's see if this will be accepted. And it is accepted, and it is performing quite good, but still low on the memory side. Okay, yeah, because we have because this is an object and this is a function, so it will take some memory. Let's try submitting it again. Hopefully this time it will have impressive space. Yes, now it's fine. Now it's good. We are beating 80%. Time is also 100%. So yeah, it's a good solution now. And so yeah, this is the bottom up constant. Now the time complexity. So at first we have seen. So at first we have seen a recursive solution. Recursive. And then from recursive we have made a memoization solution. From memoization we have built, or you can also say, top down solution. From top down we have formed a iterative DP solution, that is also known as bottom up. And then we have even optimized it to the constant space solution. Now the recursive solution will have a time complexity of order of 2 raised to the power n, and the space complexity will be n because we are using n, there will be n recursive stacks. The time complexity for this memoization part will be equal to linear, but the space complexity will be linear as well because of the DP vector and the recursive call stacks that will be performed. In the iterative DP, we are using linear time, but we are also using a data structure DP that is also linear, so it will be NN. And in the constant space time, the space will be constant, that's for sure. And the time will again be linear because it's nothing but a bottom up DP with linear time. And these are the time complexities. This is the best solution. Space is constant, time is linear. So yeah, and this was the problem. I hope you have it, my video have helped you in learning few concepts. If you still have any doubt, you can ask me in the comment section and I will try my best. Or you can also ask for a problem. If you are struggling on a problem that you're not able to solve from LeetCode or any other platform, then I will try my best to make a video about it. So yeah, that's it, and thanks for watching. Have a good day.